Hi everyone, today I will be explaining experiment 3 multi-layer perceptron on non-linearly separable data. Objective. The main objective of this experiment is to understand how a multi-layer perceptron or MLP can solve problems that cannot be separated by a straight line, such as the XOR problem. A single layer perceptron can only solve linear problems, but the MLP, which has one or more hidden layers, can handle complex non-linear relationship. Let's go through into the program explanation. First, we import the required Python libraries NumPy for numerical operation, Pandas for handling data, and Matplotlib for plotting graphs. Next, we define the input and output data. Here, X represents the input pairs of the XOR function 0, 0, 0, 1, 1, 0, and 1, 1. Corresponding outputs Y are 0, 1, 1, 0. This means XOR outputs 1 only when the inputs are different. Then we define the structure of our network. N underscore x is equal to 2 means we have 2 input neurons. NH equal to 2 means there are 2 neurons in the hidden layer. NY equal to 1 means 1 output neuron. We also initialize random weights for the hidden layer W1 and output layer W2. These weights are adjusted during training to minimize the error. The sigmoid activation function is defined next. It takes any value and between 0 and 1, helping the model learn non-linear relationship. Then we define the forward propagation function. In this step, we calculate Z1 equal to W1 into X, which gives the input to the hidden layer. Then we apply the sigmoid activation to get A1, which is the output of the hidden layer. Next, we calculate Z2 equal to W2 into A1 and again apply sigmoid to get A2, which is the final predicted output. After that, we define the back propagation function. This is where the network learns by adjusting weights. We find the difference between the predicted output A2 and the actual output Y. Then we calculate gradients for both layers dW1 and dW2 and update the weights using the learning rate, which is set to 0.1. This process repeats for 1000 iterations, 10,000 iterations, allowing the network to minimize the loss function. We store the loss value at each step and plot it at the end using Matplotlib. The loss curve gradually decreases, showing that the model is learning. Execution and results. After training, we test the model with all 4 XOR input combinations. The program prints 1 0 equal to 1, 1 1 0, 0 1 gives 1, 0 0 0. These are exactly the correct output for XOR. This provides that the MLP successfully learned the nonlinear relationship between the input and outputs. Conclusion. In this experiment, we learned that a single layer perceptron fails to solve the XOR problem, but by adding one hidden layer and using nonlinear activation function, an MLP can easily learn it. This is the core idea behind model deep learning, stacking multiple layers to understand complex data. Thank you.